All right, kidlets, we are solving the system of equations using an augmented matrix. When we do that, what we are looking to do is get rid of certain terms in the matrix. We want to eliminate this bottom left term, and we do that one first. And then we're going to second eliminate the term above it, so row 2, column 1 term right there. And then third, we're going to eliminate the row 3, column 2, or that middle term on the bottom. And we always go in this order, bottom left, the one above it, and then the one to its right. And we always eliminate in that order. So first I'm going to address this 3, and I want to eliminate it. I want it to be 0. And so what I need to do is I need to find a way to use the -2 or the 5 to make this 3 0. Now, I do that by adding the rows together. And so right now, 3 plus -2 is 1. That's not 0. That's not what I want. And 3 plus 5 is 8. That's not 0. That's not what I want. And so what I need to do is I need to modify the -2 or the 5 into something that will help me eliminate the 3. Well, since neither -2 nor 5 is a factor of 3, I can't multiply anything by them to get 3. I'm going to have to change both one of these terms and the 3. So both things will have to be multiplied. I notice that the 2 is negative, and so I'm going to use the 2 to eliminate the 3 because it's negative, which means I already have opposite signs. So what I'm going to do, guys, is I'm going to take row 3, and I write row 3 because that's the one I'm changing. Even though I'm using row 2, I'm only changing row 3, so nothing else will change. Row 3 and then an arrow, that means row 3 is going to become, 2 times row 3, 2 times that 3 right there, 2 times row 3 will give me a 6 right here, which is good. And then plus 3 times row 2. And 3 times this -2 right here is a -6. So +6 and -6. And if I add +6 and -6 together, I get 0. And that's what I'm doing. I'm saying 2 times the 3, which is +6, plus 3 times the -2, which is -6. So +6 plus -6, that's 0. It gives me a 0 there, which is really good. That's what I want. Now, it does modify the rest of the matrix, but so we'll have to deal with other numbers here. But it gives me the 0 in this place, which is what I want. So I'm going to write my new matrix here. This is 5, -4, -6, and 21, -2, 3, 4, and -15. And those stay the same. None of that changes. But then the bottom row changes. So this becomes 2 times the 3 from row 3 plus 3 times the -2 from row 2. And this becomes 2 times the -7 from row 3 plus 3 times the 3 from row 2. And this becomes 2 times the -5 from row 3 plus 3 times the 4 from row 2. And then over here in the solution column, we have 2 times the 15 from row 3 plus 3 times the -15 from row 2. And there's our solution column. We'll draw another line there just to make it clear. I know it's kind of hard to see. If I take these terms right here, this is 6 minus 6, which is 0. That's good. That's what I wanted. This is my second term. This is -14 plus 9. Third term is -10 plus 12. And this term right here is just -15. It's 30 minus 45. Okay, so now I'm going to rewrite the matrix that I have. So I've got -5, or not -5, guys, sorry. That's why you always write in pencil, right? 5, -4, -6, and 21. -2, 3, 4, -15. And then this is 0, that's what I wanted, so that's good. -5, 2, and -15. And now what I want to do is I want to get rid of this -2 right here. And the only thing left for me to use to get rid of that is the 5 that's above it. I can't make 5 into 2 easily or 2 into 5 easily, so what I'm going to have to do is I'm going to have to modify them both. Now I'm using this 5 to eliminate the 2, but I'm only going to change row 2. Only row 2 will change. And so I'm going to say, okay, row 2 is changing. Row 2 is changing, and it's going to change to 5 times row 2, 5 right there, plus 2 times row 1. Because if I multiply row 2 by 5, that's negative 10. And if I multiply row 1 by 2, that's positive 10. If I then add them together, then I get negative 10 plus 10, which is 0. And that's what I want right there. This is going to change the rest of the values on this row, but that's okay. I'll deal with that. Okay. So now I'm going to modify just row 2. I'm using row 1, but I'm only modifying row 2. So row 1 is 5, negative 4, negative 6, 21. Hopefully that's spaced out enough this time. And this is 5 times the negative 2 from row 2 plus 2 times the 5 from row 1. This is 5 times the 3 from row 2 plus 2 times the negative 4 from row 1. 5 times the 4 from row 2 plus 2 times the negative 6 from row 1. And 5 times the negative 15 from row 2 plus 2 times the 21 from row 1. And then row 3 stays the same, 0, negative 5, 2, negative 15. This is negative 10 plus 10, and that's 0, which is what we want, which is good. So this is 15 minus 8. This is 20 minus 12. And this is negative 75 plus 42. And so the matrix I have at this step is going to be 5, negative 4, negative 6, 21, 0, 7, 8, negative 33, 0, negative 5, 2, negative 15. Okay, and what I need to do at this point is I need to eliminate this negative 5 right here. And I'm going to use the other rows to eliminate the negative 5. I need to use row 2 to do that. And so I'm going to multiply row 2 by 5 and row 3 by 7. And so again, because I can't easily make 5 into 7 or 7 into 3. So this is row 3 that is changing, and just changing into 7 times row 3, because 7 times negative 5 is negative 35, plus 5 times row 2, because 5 times 7 is positive 35. And so what that will do is it will make this a negative 35 and a positive 35, and when I add them together, it will become 0. All right, so nothing else changes. All the other rows stay the same. This is 5, negative 4, negative 6, 21. And this is 0, 7, 8, negative 33. And row 3 becomes 0, and then 7 times negative 5, and that's from the third row, plus 5 times the 7 from row 2. And then 7 times 2, plus 5 times the 8 from row 2. And then 7 times the negative 15, plus 5 times the negative 33 from row 2. Put our little solution bar there. All right, and so what I get here, guys, is, and I did not write this out, but it's just 0, but it's 7 times the 0 from row 3 plus 5 times the 0 from row 2. So that's just 0 plus 0, which is 0. This right here is negative 35 plus 35. This is 14 plus 40. And this is negative 105 minus 165. And so what we have now is we have a matrix that's going to look the way we want it to look. So I'm just going to write that next to it right here. Okay, this is 5, negative 4, negative 6, 21, 0, 7, 8, negative 33, 0, 0, 54, and negative 270. Okay, and what we have now is a matrix, and we could continue and eliminate the 8, the negative 6, and the 4. But if you remember that what we started with was a system of equations and that this matrix just represents a system of equations, then you know that what I have right here is the equation 54z is equal to negative 270. And what I have here, right here, is 7y plus 8z is equal to negative 33. And what I have here is 5x minus 4y minus 6z is equal to 21. And I cannot solve this equation or this equation right now, but I can solve the 54z is equal to 270. So that's what we're going to do, is we're going to solve that equation and see what happens. So 54z is equal to negative 270. That is a one variable equation, and we solve that by dividing by 54. And what we get is z is equal to negative 5. Negative 270 divided by 54 is negative 5. Well, that is the solution for z, and I also have from the matrix 7y plus 8z is equal to negative 33. And so I now know z, which means that I can take that negative 5 and I can plug it in where that z is. So this becomes 7y plus 8 times the negative 5 is equal to negative 33. So 7y minus 40 is equal to negative 33. Add 40, and what we get is 7y is equal to 7. Divide by 7, we get y is equal to 1. And so now I have z equals negative 5 and y equals 1. And now at this point, I just have the 5x minus 4y minus 6z is equal to 21 left. That's my last equation. And I know that z is negative 5 and that y is 1. So I take the negative 5 from here and the 1 from there, and I plug them in. So I get 5x minus 4 times 1 minus 6 times negative 5 is equal to 21. So 5x minus 4 plus 30 is equal to 21. 5x plus 26 is equal to 21. Subtract the 26 from both sides. 5x is equal to negative 5. Divide by 5. X is equal to negative 1. And so my solution to this system, my solution is negative 1, 1, negative 5, right? X equals negative 1, y equals 1, and z equals negative 5. And remember that these equations here, these equations that I have here, these equations came from this matrix here after I had eliminated these three numbers. I eliminated the bottom left and then the middle left, and then I eliminated bottom middle right here. So I eliminated these three numbers, and I ended up with an equation that I could solve quickly and easily, and that's where these equations came from, is that matrix right there. All right, kidlets, I'm sorry for the interruption in the middle. Somebody came into my room, but we just kept going. I hope that this is helpful, and I look forward to talking to you about it on Monday.